Welcome to solverfy.
We're given an integral, and we're asked to evaluate this integral by the same method as in exercise 55. So the integral is from 2 to infinity of 1 over x times the square root of x squared minus 4 dx. What makes this integral special is that it is clearly an indefinite integral, not only because we have an infinite integrand, that is, the limit is improper, but also because our function on the inside is discontinuous at x equals 2. So there's really 2 points of indefiniteness. However, we can evaluate this integral by writing it in 2 different methods. So first, we'll use a u substitution. Now we recognize that in the denominator here, we have a x squared minus 4, and we have a square root of that. This suggests maybe some kind of trig substitution. For example, consider x equals the square root of 4, or 2 secant of t. Then it follows that dx is equal to, finding the differential, this is 2 secant t tangent t dt. And so the integral of 1 over x times the square root of x squared minus 4 dx, well, this becomes the integral of 1 over, and then x we know is 2 times the secant of t times the square root of, this is 4 times secant squared of t minus 4, and then dx becomes 2 secant t tangent t dt. At this point, the secant t's cancel out. We have the integral of tangent t over, and then in the denominator, the 2's also cancel out. We have the square root of 4 and secant squared t minus 1. This is the same as tangent squared t, so this is really 2 times the square root of tangent squared t dt using trigonometry. And then we can simplify by taking the square root, and we get the integral of tangent of t over 2 times the absolute value of tangent of t dt. Now the question is, can we or can we not drop the absolute value? Well, this kind of depends on what domain you're using. So we know that x lies between 2 and infinity. We also know that x is equal to 2 secant t, so secant t is going to lie between 1 and infinity. What does this tell us about t? Well, this is the same thing as cosine t has to lie between 0 and 1. This, of course, means that t is going to have to lie between negative pi over 2 and positive pi over 2. And we also have that t cannot be equal to 0. In fact, it can't be equal to any multiple of pi. Now, if t lies between negative pi over 2 and positive pi over 2, well, it's not really clear exactly what the sign of tangent t is going to be. In fact, since we're just looking at the inverse cosine, we're really only concerned about t between 0 and pi over 2. For these values of t, it follows that the tangent of t is going to be greater than 0. Therefore, our integral simply becomes the integral of 1/2 dt, which is 1/2 t. Now, we have that x is equal to 2 secant t, so 1/2 of t, this is going to be equal to 1/2 of the inverse secant of 1/2 x This is one way of looking at it. So now we can split the integral at any number between 2 and infinity. So for example, we could split it at 3. So our integral from 2 to infinity of 1 over x times the square root of x squared minus 4 dx is equal to the integral from 2 to 3 of 1 over x times the square root of x squared minus 4 dx plus the integral from 3 to infinity of 1 over x times the square root of x squared minus 4 dx. Notice that these are both improper. This one on the right is improper because the limit is infinity, while the one on the left is improper because the function is discontinuous at x equals 2. So, to evaluate, we'll write these as the limit as a approaches 2 from the right of the integral, which we know the antiderivative is now 1/2 inverse secant of 1/2 of x evaluated from x equals a to 3 plus, and this is now the limit as b approaches positive infinity of, again, our antiderivative 1/2 inverse secant of 1/2 x from x equals 3 to b. So plugging in, this is the limit as a approaches 2 from the right of 1/2 inverse secant of, this is 3/2 minus 1/2 inverse secant of a over 2 plus the limit as b approaches infinity of 1/2 inverse secant of b over 2 minus 1/2 inverse secant of 3/2. So it's easy to see that the 1/2 inverse secant of 3/2, these cancel out. And so we're simply left with, well, if we let b approach infinity, the inverse secant, as b approaches infinity, well, this is 1/2 times the inverse secant of infinity minus one half times the inverse secant of 1. Now the inverse secant of 1, this is pretty easy. This is the same as the inverse cosine of 1, which is 0. And so we're simply left with 1/2 times the inverse secant of infinity Now, secant is going to be equal to infinity when cosine is equal to 0. So this is the same as 1/2 times pi over 2 by inverse functions. And this is pi over 4. And so we get our answer pi over 4.